हेलो एवरीवन, नमस्कार, आदाब, सुप्रभात, गुड मॉर्निंग, सत श्री अकाल, अस्सलाम वालेकुम, वणकम। कैसे हैं सब लोग? व्हाट्सअप। सो आई वेलकम यू ऑल टू दिस important session for all the HPCL aspirants. So in this session we will be discussing some questions related to fluid mechanics, heat transfer and thermal engineering. So first of all, please do let me know if my audio and visual quality are fine so that we can start our session. Can you guys properly hear me? So as you all know that HPCL examination is very close and you should have your last moment revision through the question so that it will help you to perform very well in your examination. So all the questions I have brought which are having the difficulty level as that of your HPCL exam only, so that you become more confident, you become more positive and you should perform great in this examination. Hi Vijay, welcome. So keep your pen on notebook and try to solve the questions before I discuss the answer with you. Right? So shall we start? Please do let me know if my audio and visual quality are fine. Can you guys properly hear me? Good morning, Sayers. Welcome. Please settle down fast. We are about to start our session. So you are watching me live through our faculty YouTube channel, faculty driven YouTube channel, that is Resultant. So please do not forget to like this session and share with all your friends and colleagues, and do subscribe our Resultant YouTube channel also. So this is my quick introduction for those who are attending my session for the very first time. I am mechanical engineering graduate from IIT Delhi, having more than 12 years of teaching experience. I have also cleared engineering services examination, worked in SAIL also for a couple of years, and these are my favorite subjects. You can join me on the Telegram also. My Telegram channel is Mechanical by Chandrasekhar. Or you can connect with me through my official mail ID, that is chandra@resultant.in. We are selling the HPCL test series also for $399. If you are interested, you can purchase, and along with that we will be providing you the free practice tests. And we are running the paid courses also for GATE 2025 as well as other competitive examination. If you have anything to ask regarding our paid courses, you can always connect with the mentioned number. All right, or you can connect for civil. If you are civil engineering students, you can connect with the Abhinav Negi sir. If you are mechanical engineering student, then you can connect with Dheeraj sir for more details about our Resultant platform, our paid courses, our offerings to all the students. This is our mechanical engineering team, and let us start with question number 1. The question number 1 is from the fluid mechanics. Yes, try to solve this one and let me know the answer through the comment section. I am not going to solve it. I want everyone to keep solving and give me the answer. The question is from the buoyancy and flotation. A piece of metal of specific gravity 3.4 floats in mercury. The fluid is mercury and density of mercury is around 13,600. It is given, specific gravity is given as 13.6. What fraction of its volume is under mercury? There is a metal block, some portion is under mercury. Let me call it as volume of fluid displaced. Total volume is V. How much is the value of VFD by V? What will be the answer? Hi Santosh, welcome, good morning. So because it is in vertical equilibrium, because the metal is in vertical equilibrium, so buoyant force exerted by the mercury should be equal to weight of metal, isn't it? Vertical upward force should be equal to vertical downward force. There are two forces acting in vertical direction. So buoyant force is density of the fluid, that is mercury, into G into volume of the displaced fluid. Volume of the fluid displaced by the by the volume of mercury displaced by the metal is equal to volume of the metal which is inside the mercury is equal to weight of weight of metal, that is density of metal into G into total volume of metal. So we can find out VFD by V is equal to, what is that? Density of metal upon density of mercury, or the ratio of specific gravity. Specific gravity, that is 3.4 is the specific gravity of metal and 13.6 is the specific gravity of mercury. What will be the answer? What will be the answer? It is 34 by 136. The nearest option will be treated correct. It will not be completely inside the mercury. It will not be half inside the mercury. It will not be 3/4 inside the mercury, isn't it? It will not be. It is only 1/4 inside the mercury. 34 by 136 is almost 1 by 4. 0.25 is the correct answer. Well done. Question number 2. That is from the heat transfer. Question number 2 is from the heat transfer. Read the question and try to solve it. The glass windows of a room have a total area of 10 meters square and the glass is 4 mm thick. The thickness of the glass is 4 millimeter. The quantity of heat that escapes from the room by conduction, the mode of heat transfer is conduction, per second. It means it is the rate of heat transfer we need to find out when the inside surface of the window is 25 degrees Celsius and outside surface area are 10 degrees Celsius. The value of thermal conductivity of the glass is given as 0.84. It is simple Fourier law. The question is simply from the Fourier law. Can you solve it? Q, conduction, is equal to K into area normal to the direction of conduction into temperature difference upon thickness. What is thermal conductivity? 0.84. What is area? Total area of all the walls, 10 meters square, into delta T, inside temperature minus outside temperature, upon thickness, that is 4 into 10 to the power minus 3. That will be answer in joule per second or watt. What is the answer for question number 2? Can you solve it? Can you guys solve the question number 2? Question number 2. What will be the answer? I am waiting for your answer. Without calculator, please try to solve it. If you remove this point, then it is 100. So it will be 4 multiplied by 24, that is 21. So 21 into 15 divided by 0.1, or we can say 21 into 150. How much is that? It is around 3000 into 10, 150 into upon 0.1. So it is around 30,000. It is around 30, more than 30,000. 31.5. Yes, Nikhil, well done. Good, good. D will be the correct answer. Well done. Good. Question number 3. It is again from the fluid mechanics. Question number 3 is from the fluid mechanics. A water jet of cross-sectional area. There is a jet of water of cross-sectional area 0.01 meter square impinges normally on a flat plate and falls down, grazing the plate tangentially. After striking the plate, the fluid is moving in tangential direction. If the force exerted is 490 Newton, as a result of this impact, what will be the velocity of the jet? Very, very simple question. It is the case of jet striking normal to the plate. Water jet is striking normal to the plate. The force exerted will be Fn. So it is the rate of change of momentum in normal direction. So Fn is equal to mass flow rate rho AV into change in velocity in normal direction. That will be your Fn. The question is from the velocity. Velocity is Fn upon rho into A under root. What is the normal force? 490. What is the density? It is the water. The fluid is water, so 10 to the power 3. What will be the area? 0.01 meter square. So do the calculation, you will get the answer 7 meter per second. Yes, that is correct. Question number 4 on the screen. Question number 4. Well done, Nikhil, Shreyas. Keep it up, guys. Those who are not writing the answer in the comment section, please do it, because it is the fact that the more you practice, the more you share your knowledge, the more confidence you develop. So even if you are not getting the right answer, it does not matter, but participation is what highly matters to improve your confidence in the examination. What about question number 4? Yes, what about question number 4? Which of the following is a disadvantage of pitot tube? Pitot tube is used to measure the velocity. Velocity of the flow, pitot tube. What is the correct answer? Pitot tube is a long bent pipe having a, it is a bend pipe having 90-degree bend like this, to use to measure the velocity. When the fluid strikes and it is kept aligned with the flow, this is how, because it is having a vertical limb, because of vertical limb, the sensitivity of this instrument is very low. Because of the vertical limb, its sensitivity is very low. It is not difficult to install and remove. It is very easy to install, it is very easy to remove. It is very expensive, that is incorrect. It is a bend pipe, short, having a short bend. It is an open-ended tube having a short bend, 90-degree bend. It has no moving parts, which help in minimizing the friction losses. That is the advantage actually. That is not a disadvantage. It is not having any moving parts. Question number 5th on the screen, again from the fluid mechanics. Yes, 4th A was the correct answer. If the atmospheric pressure at a place is 750 millimeter mercury, that is in terms of head of mercury. This is atmospheric pressure at a particular location. Atmospheric pressure is always local because it varies with the height and with the weather condition. So it is always the local value. And the gauge pressure is 150 millimeter mercury corresponding to. So atmospheric pressure is given, gauge pressure is given. What will be the absolute pressure? Very, very simple. Absolute pressure at any point is equal to atmospheric pressure that at that location plus gauge pressure. Atmospheric pressure is 750 plus gauge pressure is 150. So the answer will be 900 millimeter of mercury absolute. Because options are having absolute, it means we need to find out the absolute pressure. C will be the correct answer. Absolute pressure is 900 millimeter of mercury. And if we want to convert it into Pascal, then density of mercury into G into 0.9 Pascal. This will give you the answer in Pascal, rho GH. Let us move to question number 6. Question number 6 on your screen. Yes, quickly. Question number 6 is waiting for you. Very, very simple. Question number 6 is very simple. Just the definition of specific gravity. Yes, quickly. Give me the answer. A metal block of specific gravity of 2.7. The specific gravity of metal block is 2.7. What will be the density? Specific gravity of a substance is the ratio of density of the substance to the density of standard fluid to the density of water at 4 degrees Celsius. If you want the density, then specific gravity upon into density of water. specific gravity 2.7 into 10 to the power 3 will be the density of water. The answer will be in kg per meter cube. D. Question number 6. D is the correct answer. Yes, Reyes, Nikhil, well done, Santosh. Please do write the question number also, so that I also come to know whether you are giving the answer to the given question or the previous question. Sometimes students give the answer to the previous question, and I assume that they are giving the incorrect answer. So do mention the question number also. Question number 7 is on your screen from the heat transfer. The relation between emissive and absorptive power of a body will be given by. This is from the radiation mode of heat transfer. All the laws are related to radiation. So which law relates the emissive power? Do you remember this? Emissive power of a body divided by absorptivity of that particular body is always constant. That is equal to emissive power of the black body. Do you remember this? Or we can say E upon EB is equal to alpha, and emissive power of the body upon emissive power of the black body is nothing but emissivity is equal to alpha for a particular temperature. Emissivity is equal to absorptivity. So the emissive power and absorptive power is related by this Kirchhoff's law of radiation. Kirchhoff's law of radiation relates the emissive power and absorptive power. Again, question number 8 from the radiation mode of heat transfer. Planck's law describes the spectrum of radiation. All the laws except the Kirchhoff's law of radiation is valid for the black body. So Planck's law is describe the spectrum of black body radiation, isn't it? So according to Planck's distribution law, E lambda B, monochromatic emissive power of a black body is directly is function of temperature and emissivity. If we draw the diagram for E lambda B to lambda, the curve will be something like this. This is how this will be lambda max corresponding to EB max. This is called as spectral distribution curve. A will be the correct answer. It will be A. Planck law describes the spectrum of a black body radiation. A will be the correct answer. Santosh. Question number 9. The Peclet number, again from the heat transfer. Do you know what is Peclet number? The next one, the Peclet number may be interpreted as the ratio of. Peclet number is defined in forced convection. What is Peclet number? Is product of Reynolds number into Prandtl number. In case of free or natural convection, Rayleigh number is defined, that is the product of Grashof number into Prandtl number. There are two types of convection, free and forced. So Peclet number is defined in forced convection. So if we write the Peclet number, then rho VL by mu, that is the Reynolds number, and multiplied by what is Prandtl number? Prandtl number is kinematic viscosity upon thermal diffusivity. Kinematic viscosity is mu by rho upon thermal diffusivity is K by rho C, rho Cp. So if we simplify this, Prandtl number is mu Cp by Kf. That is the property. So mu Cp by Kf. Mu and mu getting cancelled out. Cp is related with heat storage capacity and Kf is conduction ability. The ratio of heat storage to the heat conduction. Peclet number is interpreted as the ratio of heat capacity rate of the fluid. Heat capacity rate, it means thermal capacity means heat storage capacity of the fluid in the boundary layer to the axial heat conductance of the boundary layer. Question number 9, A will be the correct answer. Conductive resistance to convective resistance is Biot number, or it is Nusselt number. It is also R conduction upon R convection. The only difference is in Biot number conduction is for solid, but in Nusselt number conductive resistance is for a fluid. Right? So C cannot be true. Convective resistance to conductive resistance is nothing. Heat convected by buoyancy. Buoyancy is used in free convection. So that is how you can rule out. B, C, D cannot be possible. Even if you do not know the correct answer, if you can use the reverse approach or elimination approach, then you can get the correct answer. All right. So A will be the most appropriate answer for the Packlet number. I hope it is clear to everyone. Give me yes. Is this all clear to all of you? Now the next question, question number 10 on your screen from the fluid mechanics. Question number 10. Newton's law of viscosity. It is related to the viscosity. Newton's law of viscosity is related with what? What is the mathematical expression for Newton's law of viscosity? According to Newton's law of viscosity, shear stress, that is denoted by tau, is directly proportional to rate of shear strain, or we can also call it as velocity gradient, because rate of shear strain, that is d theta by dt, is equal to du by dy. It is related with the rate of shear strain and shear stress. It relates shear stress and velocity gradient, du by dy. A will be the correct answer. Question number 10A will be the right answer. Well done, Shreyas, Santosh, Nikhil. Great guys. Keep it up, Nikhil Pal. Question number 11. Very simple. This type of question are mostly expected in your HPCL examination. This is the level. This will be the level for your HPCL exam. A body floats in stable equilibrium. Condition for stable equilibrium. If it is a submerged body, you should always remember BAG. For the stable equilibrium, center of buoyancy should always lie above the center of gravity. For a floating body, you should always remember MAG. Meta center must lie above center of gravity. The meta center must lie above center of gravity. Yes, D will be the right answer. Well done, well done, well done. Right? You can definitely expect one question from this concept in your HPCL examination. Now, few questions are from the thermal engineering. What will be the answer to this? Question number 12. It is question number 12. Is it question number 12? Yes, question number 12 on the screen. Match the following. In the list 1, there are type of thermometer. In list 2, the thermometric property. What is the thermometric property? The property which is used to determine the temperature of unknown system or unknown temperature of the system. So if the thermometer is mercury in glass, the mercury expands due to heating. It is the expansion means it is the increase in volume. So the rise in height or the increase in volume is the deciding parameter for temperature. So the mercury in glass, which we generally use for measuring the body temperature, so it is volume is the thermometric property, right? Thermocouple. Thermocouple is based on Seebeck effect. When there are two junctions maintained at different temperature, due to the difference in temperature of the two junctions, the EMF is generated, the potential is generated, which gives us the information about the difference in temperature for the test junction as well as the unknown temperature junction. So it is EMF, voltage or EMF, A3B4 voltage, or we can call it as electromotive force, EMF will be the thermometric property. Thermistor. Thermistor is known as resistance thermometer, which is based on balanced Wheatstone bridge principle. It is based on Wheatstone bridge. You must have studied in your first year. So resistance will be, thermistor will be having the resistance as the electrical resistance will be the thermometric property. Constant volume. If volume is constant, then pressure is directly proportional to temperature, yes or no, from the ideal gas equation. So pressure will be the thermometric property, yes. So A2, A3, B4, A3, B4, A3, 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 B4, 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 C2 and D1. D will be the correct answer. Well done. D will be the right answer. The next question, question number 13. The next one is on your screen. Question number 13. When a system is taken from state A to state B along the path ACB, this is path 1. 180 kilojoule of heat flows into the system and it does 130 kilojoule of work. Figure, you can see how much heat will flow into the system along the another path ADB. This is, let me call it as path 2. How much heat will flow into the system if the work done by the system along the path ADB is 40 kilojoule. Do you agree in path 1 and path 2 the initial and final states are same? So there is no change in or change in internal energy. A to B will remain constant, isn't it? The change in internal energy will remain constant. So we can say delta U for path 1 will be same as delta U for path 2. Are you getting it? The change in internal energy, because internal energy is a point function, it does not depend on the path. As long as initial and final positions or final states are same for a system, then the change in internal energy will also be same. So it will be same for both the paths. So we can say Q is equal to delta U plus W. That is our first law of thermodynamics. Because delta U is same, so delta U is equal to Q minus W will remain constant. So Q minus W for path ACB will be equal to Q minus W for the another path ADB. For first path as well as for second path, the value of Q minus W will be same. In first path, 180 kilojoule of heat is flowing into the system. When the heat is added to the system, it will be positive 180 minus work is done by the system. It does 130 kilojoule of work. So again it will be plus 130 is equal to Q, which is unknown, and work done by the second path is 40, again positive. So Q minus W is 40, or we can say plus 40. This will give you the answer. 180 minus 130 is equal to Q minus 40. Can you find out the value of Q? 90 kilojoule. Kya? 90 kilojoule will be the correct answer. I hope you understood this. C will be the right answer for the given question. Question number 13, option C is the correct answer. Option C, right? Anybody is having any doubt, you can just let me know. Otherwise, let us move to question number 14. Question number 40 on the screen. There is an expansion of a gas from pressure P1 to pressure P2, and the relation between P1 and P2 is also given. Because there it is an expansion means decrease in pressure, increase in volume. If the process of expansion is isothermal, the volume at the end of expansion is 0.55 meter cube. If the process of expansion is adiabatic, what will be the volume at the end of the expansion? Will be close to. Question number 14. Can you do it? Can anybody let me know the answer? Question number 14. There are two types of expansion from the same initial point, but the final points are different. The first process is isothermal, means the temperature is constant. The second process is adiabatic, it means there is no heat transfer. So what will be the volume of the gas at the end of expansion when the expansion is adiabatic, and the volume at the end of expansion is 0.55 given for isothermal. Yes, question number 14, anybody had given me the answer? If we draw pressure versus volume diagram, point 1 is same for both the process. This is, let us say, P1. P1 is same. Now, if you draw isothermal expansion, it will be something like this. Temperature is constant. This is, let us say, 2. 1 to 2 is isothermal. And at the end of isothermal, the volume is given as 0.55 in meter cube. Right? Now, if the process is adiabatic, do you know that the slope of adiabatic process is greater than slope of isothermal on PV curve? The slope of adiabatic process. The slope of adiabatic process is gamma minus P by rho, P by V. Gamma times of minus P by V, which is greater than minus P by V, negative slope. So slope is more. If we draw the curve for adiabatic process from the point 1, then it will be more steeper like this. This is expansion, isn't it? And we are talking about the same point. We are talking about the same pressure. P2 is same in both the cases. What is P2? It is P1 by 10. So if we draw adiabatic process, it will look like this. So definitely the volume will be less than 0.55. For adiabatic, it is Q is equal to 0 process. For adiabatic process, volume will be less than 0.55. It cannot be equal to 0.55. It cannot be more than 0.55. The only probable option is 0.45. Yes. Question number 14, A will be the correct answer. Constant temperature, the slope of constant temperature process is less compared to the slope of constant slope of adiabatic process. Adiabatic process is having more slope than the isothermal process. That is what the concept is. It is not at all a numerical, it is just the conceptual question. I hope you understood it. A will be the correct answer. Question number 15. Next one is question number 15. Read the question carefully and try to give me the answer. Read the question and let me know the answer. It is assertion reasoning. It is assertion reasoning question. The heat is added during a polytropic process. What is a polytropic process? PV to the power n is equal to constant. Along with the heat transfer, there is a work transfer also. Polytropic. If the process is neither of isothermal, adiabatic, isochoric, isobaric, then it is called as polytropic process. Though heat is added in Q is positive, in polytropic expansion process for which gamma is greater than N is greater than 1, the temperature of the gas decreases. Even if we add the heat in case of polytropic process, then the temperature of the gas decreases during the process. The reason is the work done by the system exceeds the heat added to the system. What about this? Look, if we write Q for a, let me add one slide. Just give me a moment. Look, if we write Q for a polytropic process, then it will be M into C for a polytropic process into delta T. This is the formula where C for a polytropic process is N minus gamma upon N minus 1, which is less than 0, which is negative. Why? Because N is less than gamma. So specific heat for polytropic process is negative. So if this is positive, let us say, if this is positive and C poly is already negative, then if the heat is added, heat addition is taking place. If heat addition in taking place is polytropic process, then delta T should also be negative, isn't it? Then only that will become positive. So delta T is negative means temperature is decreasing. When heat is added to the system, temperature will decrease. So assertion is true. If heat is rejected, if this is negative, C poly is already negative, so delta T must be positive. Due to heat rejection, then temperature must increase, isn't it? This is how what is happening in polytropic process. And if the temperature is decreasing in this case, then we can say internal energy will decrease or delta U will be negative, yes or no? If heat is added, there is a decrease in internal energy and Q is equal to W plus delta U. If delta U is negative, then definitely W is greater than Q. When heat is added to the system, then the work done by the system will be greater than the heat addition. So the requirement of work done is not fulfilled just by the heat addition. So there is a decrease in internal energy. That is how we can justify that by adding the heat addition, the temperature of the polytropic process is decreasing. So assertion is true. The reason says the work done by the system exceeds the heat added to the system. That is also true. That is why internal energy will decrease or temperature will decrease. So assertion and reason both are individually true, and the reason is the correct explanation of assertion. Hi Ashutosh, welcome. Good morning. So we are discussing the questions for HPCL examination. That subjects I have included are fluid mechanics, thermal and heat transfer. I hope this question is clear to everyone. Next, let us move to question number 16. Question number 16 on the screen. Question number 16 on the screen. Match the following. Match list with list 2. In list 1, they are steady flow devices. In list 1, there are steady flow devices. And in list 2, this is steady flow energy equation or first law of thermodynamics. First law, how the first law of thermodynamics is getting converted, how the first law of thermodynamics is getting converted, or the steady flowing energy equation is getting converted for different systems. Our steady flow energy equation is, let me write it as H1 plus C1 square by 2 plus GZ1 plus Q is equal to H2 plus C2 square by 2 plus GZ2 plus W. It is joule per kg. H is the enthalpy, C1 and C2 are the velocity, Z1 and Z2 are the potential energy heads, Q is the heat addition, W is the work done. If it is a turbine, there is no change in potential energy, there is no change in kinetic energy, is equal to 0, and it is thermally insulated also, Q is also equal to 0. So it means C1 is equal to C2, Z1 is equal to Z2 and Q is equal to 0. That is the turbine. So we can say turbine is used to produce work. So for turbine it is H1 minus H2. Yes or no? A4, 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 A4. Then the nozzle, in nozzle C2 is very large compared to C1. It is used to increase the velocity. So C1 can be taken as 0. C1 can be neglected. There is no change in potential energy and all the devices are normally thermally insulated. So Q is equal to 0. For nozzle we can say, what we can say, H1 plus H1 and W is also equal to 0 in case of nozzle. So H1 is equal to H2 plus V square by 2. 3. B3. And what about valve? It is throttling valve. Valve is having throttling. So it is isenthalpic. Throttling means isenthalpic. It means C2. C is incorrect, A will be correct answer. Compressor is the reverse of turbine. So compressor will have W is equal to, it is work consuming device. So D1, work consuming device. 16, option A will be the correct answer. Yes. Question number 16, option A. Let us move to the next one. Question number 17 on the screen. I hope you understood this. So if you revise, the most important in getting your selection in HPCL is to revise all the subjects before appearing for the examination. That is the only mantra. Do not practice lot of questions. Rather go for revision. Do revise each and every topic thoroughly, because the difficulty level of the question paper will be simple, but there the question can be framed from any corner. The question can be directly theoretical based on formula. So there will be simple question. Question number 17 on your screen. Question number 17. This is our volume versus temperature diagram for a thermodynamic cycle. How to represent the same cycle on PV diagram. Volume versus temperature is given. The curve representing volume and temperature is given. We need to represent this cycle on PV curve. Yes, कर सकते हैं. Question number 17. If you see, question number 17, if you see A to B is volume directly proportional to temperature. It means constant pressure. A to B is constant pressure and volume is increasing, so temperature will increase. So it is a constant pressure. A to B will be constant pressure. Constant pressure means horizontal. A to B will be horizontal. So A cannot be true. AB cannot be vertical. AB cannot be vertical. It should be horizontal. It is a constant pressure process. AB cannot be like this. A to B is constant pressure. Volume will increase because the temperature is increasing, right? And B to C is constant volume. Volume is constant, so P is directly proportional to T. If temperature is decreasing, then pressure will also decrease. If we draw PV diagram, then constant volume and pressure will decrease. Constant volume is vertical line. B to C is a vertical line. B to C is a vertical line, and B to C is a vertical line, and pressure will decrease. What about C to A? C to A is constant temperature. It means PV is equal to constant. It is isothermal. PV is constant. And because volume is decreasing, then pressure will increase. So pressure will increase and volume will decrease. Pressure will increase and volume will decrease. So D will be the correct answer. From the one single, this AB, one single process, you could have ruled out the other options easily. D is the only possible option. Is it a work producing or work consuming? Yes, it is work producing cyclic device. Clockwise cycles is work producing, anti-clockwise cycle on PV diagram is work consuming. We can find out the work produced by calculating the area of the curve. Yes, well done. The next one. What is the number? Question number 18. Next one, question number 18 on the screen. Solve the next question, question number 18. A fluid flowing along a pipeline undergoes a throttling process. I have told you, throttling is isenthalpic. H is equal to constant. From 10 bar to 1 bar. There is a process from 1 to 2, then 10 bar to 1 bar. Passing through a partially opened valve. Throttling happens in a partially opened valve. Before throttling, specific volume of the fluid V1 is 0.5 meter cube per kg, and after throttling it is 2 meter cube per kg. What is the change in specific internal energy? That is U2 minus U1 is how much in kilojoule per kg? Yes, in kilojoule per kg we need to find out change in specific internal energy. U2 minus U1. Can you find out? So H1 is equal to H2 implies U1 plus P1 V1 is equal to U2 plus P2 V2 in kilojoule per kg. So from here we can say U2 minus U1 is simply P1 V1 minus P2 V2. Put the values, you will get the answer. P1 is 10 bar, so 10 into 10 to the power 3 or 10 into 100. I am writing in kilojoule into V1. What is V1? 0.5 meter cube minus P2, that is 100 into V2. V2 is how much? 2. That will give you the answer. 500 minus 200, that is 300 will be the correct answer. 300 will be the right answer. D is the correct answer. Question number 18, D will be the correct answer. Isn't it? Any doubt? Shall we proceed further? Let us move to the next one. Question number 19. Question number 19. An engine reversibly, it is a reversible engine, receives 1200 joule of heat at 900 Kelvin after rejecting heat to the ambient at 300 Kelvin. It develops 600 joule of work. The irreversibility in joule is yes, Ashutosh, about which question you are talking? Even if it is an ideal guess, What is irreversibility? Irreversibility is ambient temperature into delta S for the universe. Irreversibility is T naught into delta S for the universe. And if we draw, there are three systems. One is the source which produces heat. Source is at temperature 900 Kelvin and it is giving heat 1200 joule. Then there is a heat engine which is producing some work and there is some heat rejected. The work produced is 600 joule and the heat is rejected to the sink. Sink means ambient 300 Kelvin. So this is our isolated system. This is the isolated system. So there are, the engine will not have any change in entropy. Engine will not have any change in entropy. There is a change in entropy for the source, there is a change in entropy for the sink. So we can say I is equal to T naught, then we can say delta S for the source plus delta S for the sink. Yes or no? Delta S for the source plus delta S for the sink. T naught is equal to 300 Kelvin. What is delta S for the source? Because there is a heat released by the source. So the source internal source entropy will decrease. So it is minus Q1 by T1. Yes or no? Plus sink will be getting the heat. So there is an increase in entropy for the sink. Q2 by T2. This will give you the answer. 300 is the ambient temperature minus 1200 upon T1, that is 900 Kelvin, plus what is Q2? If 600 joule of work is produced, Q2 will also be 600 joule from the first law of thermodynamics for the engine. So it will be 600 divided by T2, that is 300. This will give you the answer for irreversibility. 300, then it will be minus 4 by 3 plus it will be 2. What will be the answer? 300 into can you solve it? Entropy of the universe will decrease. It will be negative minus 10 by 3. So it will be, sorry, it will not be minus 10 by 3 na. It will be 6 minus 4, 2 by 3. Sorry, 2 by 3. Yes. Entropy of the universe will increase. Entropy of universe can never decrease. That is the entropy principle. So it will be 200 joule. The answer is option C. C will be the correct answer for question number 19. And one last question, question number 20. Let me know the answer for this one. Question number 20 on the screen. 19th answer is C, not D, Nikhil. Question number 20 on the screen. The last question from my side. A heat pump. What is heat pump? Heat pump is the inverse of heat engine, which operates in a cycle, extract heat energy from the cold reservoir. It is extracted energy from the cold reservoir. This is the cold, and supplies the same amount of energy to the hot reservoir Q1. Which of the following statements holds for this process? If no work is added, because it is the heat is flowing from T2 lower temperature reservoir to upper temperature reservoir. When the heat flows from low temperature reservoir to high temperature reservoir, the external work must be done on the system. If work is not zero, then it does not violate the first law of thermodynamics. First law of thermodynamics, Q1 is equal to Q2. There is a possibility. But yes, it violates the second law of thermodynamics, which says there should be external work done when the heat to be supplied from low temperature reservoir to high temperature reservoir. So it violates the second law but not the first law of thermodynamics. Yes, actually. Yes, Parag, you are correct. The values are not justifying the reversible engine. The values does not justifies the values for the reversible engine. If it would have been a reversible engine, then this would have been correct. W is this correct or not? W by Q1. So it is 1 by 2 is equal to 1 minus T2 by T1, 300 by 90. 300 by 900. It is not correct now. Either T1 should be 600 Kelvin or T2 should be 450 Kelvin. Yes, there is a problem with the question. But it is mentioned, Shubham, it is mentioned same amount of energy to the hot reservoir. It is mentioned in the question, the pump is supplying the same amount of energy to the hot reservoir. It means whatever heat is abstracted is equal to Q1, that is given. So the first law is not getting violated. First law is not getting violated, but yes, the second law is getting violated. Isn't it, Shubham? Are you getting it? So that is all from my side. So if you know that on 15th of August, we will have the final mock test for all the subjects. On 15th, there will be a mock test for HPCL for all the subjects with all the faculties of mechanical engineering. So do revise all the subjects before appearing for the mock test on 15th. So see you guys on 15th. Till then, enjoy, take care, have a good day and a great career ahead. Thank you once again, and do not forget to like, share and subscribe our Resultant YouTube channel. Jai Hind.